Welcome to January 11th LeetCode Challenge. Sum of root to leaf binary numbers. You're given the root of a binary tree where each of the node has a value of 0 or 1. Each root to leaf path represents a binary number starting from the most significant bit. For example, if the path points from 0 to 1 to 1 to 0 to 1, then this could represent the binary number 0110, which is number 13 integer. So, for all the leaves in the tree, consider the numbers represented by the path from the root to that leaf. Return the sum of these numbers. So the test case is generated so that it fits a 32-bit integer. So given this tree called root here, you have the sequence given here by 1, 0, 1, 0, 1, 0, 1. And if we were to sum all the root to leaf paths, so we have 1, 0, 0 plus 1, 0, 1 plus 1, 1, 0 plus 1, 1, 1. And those are in binary. If we convert those into base 10 integer, we have 4, 5, 6, 7, which equals the sum of 22. And if the root is 0, then we return 0, of course. So the number of nodes in the tree are ranged between 1 to 1000. Node.value is 0 or 1. Okay, let's see if there's a hint here. Probably telling us recursive. For each path, transform the path into base 10 integer. Alright, that might be useful. I don't know. So this is ranked easy, but we'll see how it goes. So intuitively, let's when we counted here, we went from 1, 0, 0, 1, 0, 1. That's like a preorder traversal, what we just did there. So I think like all type of binary tree type approach, we have the iterative approach and the recursive approach. I am going to go for the iterative approach for the iterative preorder traversal. Ideally, if you go in reverse, it'll still add up to the sum, it'll still be the same. But let's just go to that. And the idea is that we're going to make a stack. We push root into the stack. While the stack is not empty, we're going to pop it out from the stack and update the current number. If the node is a leaf node, then we update the root to leaf sum, and then we just push the right and the left child to the stack, and then we return the root to leaf sum. Essentially, that's the algorithm we're going to use. Alright, let's go about solving this. So we want to get rid of this edge case first, so when root is 0 itself. So let's call this root to leaf. That's going to be 0. And we're going to make a stack as stated. And the stack is going to hold two numbers, a tuple of root, not tuple, the root itself, the given array, and the sum, not the sum, the index, or the level. Alright, it's level 0. So while the stack is not empty, what we're going to do is basically take the root and the current number, current node, current number, I can call it current value, will be the stack dot pop. So basically, when the stack's not empty, we're going to pop from the stack to get the root and the current number we're at. Alright, so actually, yeah. So first thing we do is pop. Then, if the root is not none, we're going to update the current number. and we want to do the current number. It's gonna be a bitwise conversion. So basically, what we want to do is that we want a bitwise shift to the right. Let's see if I can describe this a little better. Say for instance, if you have current number, call it current number, it's easier, and you do a bitwise shift like this, and then you do a bitwise OR like that, then you get the number 3. Ideally, you need to know a bit about binary operations, bitwise operations. Alright. Oh, that's exactly what we will need to do. And then we need to do root.val. Alright, that's the second trick you need to know is bitwise operations, and the other one is basically how to traverse a preorder traversal of a tree. So if the leaf is if the node is a leaf, then we update the root to leaf value, and that's so basically if root dot left is none and root dot right is none, then we are going to update the sum of the root to leaf current number. Alright. Otherwise, we are going to append to the stack. And what are we going to append? We're going to append the root dot right with the current number. And you guessed it, we're going to append the stack with root dot left and the current number. Let's see. And those need to be tuples, or not tuples, you have 2 values inside it, because it's supposed to represent the these 2 numbers, the node itself and the current number. And then we want to return the root to leaf number. Let's just run this code briefly. So basically we're doing a iterative preorder traversal, and let's see what's going on here. It's current number, let's see. Doing, as I was saying, so that seems like it's working. Let's submit it and hope it works. Awesome. Let's see, memory-wise, speed-wise, it's actually quite slow. Its time complexity is big O of linear time, so big O of n, where n is the number of nodes. Since it has had to visit each node, right? It has a while loop to visit each node in the stack. Space complexity, we have big O of constant time space, but the space itself is actually quite small because we're keeping track of the height of the tree, which is basically here, so height 1, 0, 1, and 2. And this is basically using a iterative preorder traversal, where we basically push onto this, make a stack, pushing onto the root, and then while the stack's not empty, we basically pop from the stack and update the current number. If the node is a leaf node, what we're going to do is do a bitwise manipulation here, and then update the root to leaf and sum. And then Otherwise, we append or push onto the right child node and the left child node into the stack, and we continue the stack loop. Alright, there you go. Have yourself a great day, guys.